Hello guys, welcome back to John's Workshop. In this video I'm going to make a fly cutter, a decent sized fly cutter for the mill, and the reason I'm doing that is because I want to crack on and make the Dickson tool post adapters, and I've got some steel here already for that, some ground flat stock or O1, and I need something that's big enough to span that so that when I square all the block up and mill it down to finished size, I've got something that will do it in one sweep. So what we'll do, I'll just bring you to the bench and I'll show you what my thoughts are. I've looked some stock out of my limited supply and I think I've got what I need, and it'll be a good first project for the new lathe, even though I'm going to be using a compromised cartridge, but we'll give it a shot and see how we get on. And then onto the mill for some mill work. We'll make the fly cutter, and then we can get on with making the tool post adapters. So I'll bring you back at the bench and I'll just take you through my planning. Okay, so what we've got, so I've looked at some stock. Initially I was going to use this, which is a fly cutter that I made many years ago, and I was going to try and revive that, and that basically takes a piece of I think it's 1/2 inch high speed steel through at an angle, nipped up. It's okay, but it's there's as much work trying to make this do what it needs to do as there is to make something a bit better, so I've decided to start again. So we'll revive that at some point, but not just now. So this is what I'm going to be making out of the O1. So that's to give me an idea of size. That's what we're doing. I've looked out in my limited stock, and I've got this, which I've got no idea what it is. I've put a file across it, and it seems reasonably soft. So it's probably mild steel or something similar. But if I sit that block on top of there, you can see that that's a good size, and I'm not going to have the tool stuck out too far to span that width. So what we'll do is, I've also looked out my limited stock of high-speed steel blanks or high-speed steel tools, and I found this one, which is, what is that? That's 12 plus 1/2 inch. So 1/2 inch square, high speed steel. Don't know if it's cobalt or not, there's no markings on it, but it'll be a bit of decent quality stuff. It's been kicking around for a long time. It's nothing new and modern and imported, so it'll be a bit of decent quality high speed steel. So basically the idea being, I'm going to cut a section of this off at the right length in the saw, and then we'll turn the back end down to fit in the collet, in the biggest ER collet that I've got, and then we'll face up the front end, and then we'll put it onto the mill, and we'll mill a slot through the middle that basically puts the tool at an angle. I don't know whether you can see that on the camera. So we'll put a slot through the top that puts the tool at an angle, so that the front face of the tool is right on the centre line, so that there's no grinding to do really, other than keeping the reliefs correct and a nice radius on the corner. And then from the front we'll drill 3 holes in there, and we'll put 3, ideally I'd like to put 3 grub screws in, something like M8. I don't have any grub screws, so at the moment it'll have to be cap screws, but that'll do for now until I get some grub screws in. So that's the plan, that's what we're going to do. Right then guys, here we go. So that was a good test for the bandsaw, and it's done a good job actually. Pleased with that. I just chucked a quick square over it just to see whether it was how it had cut, and it's cut very well. So I'm sure there's a fly cutter buried deep in there somewhere. We just need to get it out. So I'm going to reposition the camera so it's out of my way a little bit, and then we'll get this set up in the chuck, and we'll see how the lathe performs. So I'll put a tool, I'll put one of the Dickson, I'll put the best of the Dickson cartridges on, and I've just chucked a tool in. I've got no idea where that is centre height wise. In fact, what we'll do is we'll just have a quick look. My neighbours are appreciating what I'm doing. Slightly under. Here we go then. First go with the lathe. Or maybe not. Let me just change the settings on this. Well, it cuts. We're still slightly under centre. Just lift that up a bit. That's a decent bit of material. I don't know what it is, but it cuts nice. Right, this end's going to be, that's a cracking finish. This end's going to be the bit that goes up into the collet. So I'm just going to grab an ER32 collet. Now what I haven't got is a carriage stop yet. So that's something that I'm going to need to make. So we're just going to have to do this without a carriage stop at the minute. So I want full depth of engagement on the collet. So I've just got a mark on there now, and we will, yeah, we're set right there. We'll have a bit of a play with that because that's not chipping. I don't know whether the insert's worn. I'm learning some stuff, just trying to get the balance of feed rate and whatnot right, so we're getting some chipping, which we are now. I'm just going to grab some measurement gear and we'll have a bit of a measure up and see where we are, and then work out whether this lays in diameter or radius in terms of the cross slide measurements. So I'll bring you back in a minute when we're getting down to final diameter. Right guys, we're getting here on finished size now. So what I have worked out is that the cross slide, what you actually put on the cross slide is actually what it takes off. So it's in diameter as opposed to radius, which is completely the opposite to the Denford. So I need to just watch that, because I'm going to catch myself out. So I've just measured up. I've been taking 50 thou cuts basically as I get down to finished size, so that I get the same level of push off. So I've done 3 50 thou cuts. Final measure cut now. There's 47 thou left to come off. So I'm just going to put that off, and we'll see. Should be finished size at that point. Check that. I'm aiming for 787. I'm working in imperial, guys, because I've only got imperial micrometers. So 787, we've got there 787. Yeah, bang on. So we'll just tidy the face up at the back. Perfect. Now what I haven't got is a 45-degree tool, and I don't want to disrupt this particularly because I've only got the one holder at the minute. So I'm just going to spin the tool post around for a chamfer, a couple of chamfers on here. Put a big chamfer on the back, because I'm just going to take a light skim off the OD, and that will just leave hopefully a decent sized chamfer on there. Then we'll just spin this round and face it off, and turn the diameter. go, guys. That's the blank of the fly cutter done. Pleased with the lathe. Now I've worked out the sort of feeds and speeds. It's not stainless, by the way. I was just doing that based on the colour of the swarf coming off. I didn't think it was when I cut it in the bandsaw. I don't know what it is, but it's a drop of good material. Is that? It's cracking finish everywhere. Like I say, I've no idea where I picked the material up from or what it is, but it will certainly do for a fly cutter, I think. So I've gone for the biggest size ER32 collet that I've got, which is 20mm, which is 0.787 in imperial, and you can see there, you know, that's a cracking fit on there. So what I did there, and I didn't explain it very well, and this is something from just learning turning and generally in my apprenticeship, and also further on in aerospace, especially in aerospace, and I'm talking on CNC applications now. What you tend to find and what you'll tend to see on YouTube, especially in home workshops, and this is no, I'm not meant to be being critical in any way, because there's people that do this stuff that have not had any formal training and they're picking it up as they go along, and I think that's fantastic. But what you'll tend to find is people will take the biggest cut that they can to get somewhere near size, and then when they get near size there'll be tiny bits and creeping up on it, and then they'll finish off with a load of emery cloth, and it gets you where you need to be normally. 50% of the time you'll go undersize slightly because you're not in control. So what I did there was, it's all about balanced cuts, and you need to be taking at least 3, if not 4, finished passes that are all the same size. So your push off amount is the same, you don't alter anything about your speeds or the feed rate or anything like that, you keep everything the same, and you dial in, you get yourself to a number that if you want to use, like I was doing 50 thou there, so you start off and get yourself to a number where you're 200 thou away from your finished diameter, and then you start dialing in your 50 thou cuts. And like you saw, my finished cut there was 47, so there was 3 thou error in that original 200 thou away from where I need to be cut that I put on. But then every cut's the same size, the machine's in the same condition, you've got the same amount of push off on every cut, and you just go straight in for your finished size. And you saw me do it there, straight in. You just got to trust yourself and trust your measurement, straight into finished size, and that's within a couple of tenths of where it should be according to the micrometer. So I'm perfectly happy with that, and it's slightly warm, and I think that'll probably shrink a couple of tenths by the time it's done. So I'll remeasure that when it's cooled down and just see what I actually finished up at. But that's, you know, if that helps somebody, that's far easier than creeping up with tiny little cuts. And another thing, you know, my surface finish on there is great because I've got everything set on the lathe to give me a good surface finish. The minute you start altering the depth of cut and you start tickling around with, especially with carbide inserts, and you're not getting under the material, your surface finish just goes to hell. It'll all be scratched and ragged up, and you struggle to control diameters when you're like that. So hopefully that's a tip. Hopefully somebody gets some value out of that. So we're done with the turning. What I now need to do is work out what I'm going to do from a milling perspective to put the slot in, where we're going to put it, and at what angle relative to the centre line of the cutter, and we'll set the mill up, and we'll start hogging out the slot for the high-speed steel to go through. Right, here we go. This is cooled down now, guys. I don't know whether this is going to show. It's not, unfortunately. No, it's not. But I've got my better micrometer out, and I've just checked that now. And 20mm is 0.7874, and with that micrometer, that's a 10th micrometer, so it's got the graduations on the barrel there for tenths. I'm measuring 7875, so that's that method that I've just shown you there of balanced cuts for semi-finishing and finishing. It works. Try it. You just, you know, if you've never tried it, just try it, because you just need to be confident in your setup and in your measurements, and if you do it properly, you'll get good results like that, and it just makes life a lot easier. Okay, we'll get this set up on the mill now for putting the slot in.